Let's now discuss how we can create what is known as a product type with some example code. There is some new syntax here and some slightly weird naming, which I will explain. The data keyword indicates that we are creating our own custom type. Then comes the name of the type, which in this case I've called datetc. Then comes an equal sign. After the equal sign comes what is known as a data constructor, and then the types of components we want for the product type, which in this case are 3 ints. Each component is simply separated by a space. We are using ints here to represent the constituent parts of the date, those being the day, month and year. We use ints for simplicity and we'll come back to better alternatives later. So we can read this code like this. We are creating a custom type called datetc, which is defined as having a single data constructor, datedc, which expects 3 ints. We also add the deriving show clause to the end of our data declaration so that we are able to print values of our newly created type on the screen in GHCI. Now, a quick word about constructors. The datetc, which you see here, which is to the left of the equal sign, is sometimes called the type constructor, hence the reason for me putting a tc in the name. We will learn more about parameters to the type constructor later when we look at polymorphic types, but in this particular case there are no parameters to the constructor, so we can just refer to datetc as the type name. The type name is what you would use in signatures to refer to the type. The datedc, which is what you see here, is to the right of the equal sign and is known as a data constructor, hence the reason for me putting a dc in the name. Sometimes people call it a value constructor instead, but they both mean the same thing. We use this constructor to create values which have the type datetc. This constructor takes 3 int arguments. Let's take a second to understand what this all means by looking at how we can create instances of our new custom type. Here we are creating 2 values, d2 and d3, which both have the same type, datetc. We refer to the type constructor's name in the type signature. And when we want to create an instance of the value, we refer to the data constructor. Remember, another name for the data constructor is the value constructor for this very reason. They are called product types because they're analogous to the Cartesian product of sets which we saw before. In other words, a value of the datetc type can contain any combination of 3 ints, just like a 3 tuple of int would be able to. But unlike a 3 tuple of ints, we have a much stronger type safety available here when we use our custom type, and our code will be more readable as well, since all type signatures will now refer to our custom type name, which is somewhat self-describing. One thing I should mention is to do with naming. As you can see, the type constructor and the data constructor always begin with a capital letter. Also, the tc and dc at the end of the constructor names in the type declaration are not actually needed. I only put them there to get you familiar with the idea of the type constructor and data constructor being 2 separate things. In actual fact, the typical declaration you would see in Haskell is more like this, and we would create instances of the type like so. And so, the date in the type signature here refers to the type constructor, and the date in the values refers to the data constructor. In Haskell, the names of the types and values are independent of each other, and so there is no actual name clash occurring. You just need to keep the namespace for the type constructor names and value constructor names separate in your head. This can be quite confusing at first, but after a while, you get used to it. It should be clear now why we are calling them constructors, because they are defined with parameters, and when arguments are given to them, they construct an instance. In the case of this particular type constructor, it does not actually take any parameters. As I mentioned earlier, we'll be looking at type constructors which take parameters when we look at polymorphic types later. So let's just focus on the data constructor for now. The data constructor acts exactly like a function would. If we ask GHCI for the type of the data constructor datetc, it responds by telling us that it takes 3 ints and returns a datetc. And you can see, when we use the data constructor, it is just like calling a function. Remember, :t in GHCI is short for :type, so when we use the :t command, we are asking for the type of a value or a function. So when we ask for the type of the date, like we do here, we get the response that it is a function which takes 3 ints and returns a date. But what date exactly? Is it the date we define here for the type constructor, or the date we define here as the data constructor? Well, the first date refers to the data constructor. This is the date which we are asking GHCI to tell us the type for, and the second date refers to the type constructor. If you get confused, then remember that the only thing that can appear in a type signature, that is, after the double colon, is a type, and so the date within the type signature refers to the type, not the value. If you are still confused, you can compare it with the type signature given for date DC here to understand which is the type and which is the data constructor. Now what happens when we ask for the type of the type constructor itself? As you can see here, we get an error. That's because you can only use :t to ask for the type of values or functions, not for asking for the type of a type, so the error is expected. We'll look at the type of types later when we cover polymorphic types. One of the definitely good things that happen when we have our own types like this is that in type signatures, our intent becomes much more clearer. By reading this type signature, you know for sure that the values are intended to be dates. This is much better than using a simple 3 tuple to represent the constituent parts. In this particular type signature, you have no clue that the 3 ints are supposed to represent a date. So using our own custom types to make things clearer and more understandable makes a lot of sense. But still, the usage of raw ints here is still error prone because they do not constrain the possible values to be only valid values. We could still construct an invalid instance of a date, like here, where we are saying that the month field has a value of 31, when obviously there is no 31st month. So we still need to learn more about types before we can fix this. But that's pretty much it for creating your own product types. It's quite simple really. You use the data keyword followed by the name of the type and an equal sign, followed by a constructor and the types of the constituent parts. And although we don't always need to, we add the deriving show clause to the end of the type declaration for convenience, so that we can see the values in GHCI, like we did here. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Liger Learn channel. See you next time.